Hi everybody, this is Ramon Alcarria. Welcome again to this course, Network Control Systems with Arduino, an introduction to technology, programming and robotics. This is module 5, location and storage, and in this third lesson, divided into two videos, we will learn how to store sensor information into a database located in a server by using HTTP requests. We will start with the required configuration for building a personal server and a database. Once the database is operational, we will test the select and insert functions. After that, we will prepare our Arduino platform for Wi-Fi connections with some advanced features such as flashing. Finally, in the following video, we will see Arduino's configuration and sketches. We build our server with XAMPP tool. XAMPP is a portable version for Windows. It can be used LAMP for Linux and other alternatives such as WAMP. When you install it, just start the Apache and the MySQL. Then, if you go to localhost in your browser, you will see the welcome page. In the control panel, if you press the shell button, you can log into the database and create a table to store your data. In the shell command line, you need to log into your database with root user. Switch to a database called test, which was created by default, and in the test database, we create an Arduino temp table. And we can also insert some data to check that the MySQL database is working as expected. With the select from command, we will check that the data is correctly inserted. We have prepared a temp read and temp write PHP files that must be located in the htdocs folder of XAMPP. By calling the temp read file in the web browser, we will list all data. By calling temp write with an argument, we will add an extra entry in the table. We are protecting our code so that an empty value of temperature is not accepted, as well as the absence of the temp parameter. We provide the error message temp value is empty. We will use the Wi-Fi module ESP8266 for Arduino connection. It has 8 pins, which include 4 general purpose input-output pins, serial communication transmission and reception pins, VCC, and ground. The way to connect it to the Arduino is the following. Transmission pin from ESP to reception pin in Arduino. If you have an Arduino with serial hardware, such as Mega, which includes 4 serial hardware pins, the reception pin will be RX1. If you have an Arduino without serial hardware, just connect it to a digital input. Then we connect the reception pin from ESP to transmission pin in Arduino. In Mega, the transmission pin will be TX1. In other Arduinos without serial hardware, just connect it to a digital output. Please be careful with the ESP module. It operates under 3.3 volts. That means that you cannot connect it to a 5-volt sources. It will damage your chip. If you use an external power source for the ESP module, always keep a common ground with your Arduino to avoid voltage differences. We will use the Wi-Fi ESP library, which does not require any flashing. In previous modules, you learn how to flash your Wi-Fi module, for example, to set up an MQTT client. If you previously flashed your module and you want to come back to your original firmware, we recommend the following serial adapter. If you do not want to flash your firmware again, you can skip the rest of this video. Please keep in mind that the remainder of this video is very technical and often not required to continue with the rest of the lessons. The serial adapter features SPI, I2C, serial UART and GPO interface pins, 8 in total, including the I2C interface pins. The board has a 3.3 voltage regulator, allowing also 5 volts. It can be powered using a micro USB cable or LiPo battery. The USB cable also charges the attached LiPo battery, thanks to the LiPo battery charging circuit on the board. The flashing circuit is as follows. In the flash process, you need to press and hold the reset button, and then press and hold the flash button. Release the reset button, and then release the flash button. For all information about flashing, please consult the documentation of this lesson. For the flashing process, we need to select a firmware image and a flashing tool. These are our recommendations. The most important step in the flashing process is to carefully select memory addresses for flashing. To check the memory space, in the flash download tool, we check the crystal size. In the figure, 8 megabit is equal to 1 megabyte. With this value, you must go to the reference document and see the files that are needed for flashing, as well as the memory addresses for each file. For 1 megabyte, we have the following table. Thus, the following files are required. Please annotate the address as we need this information. In the flash download tool, we select the files and the previous addresses we annotated for each file. That would be the flashing process. For further documentation, please consult a good manual for flashing. To verify that the flashing process results in a working Wi-Fi module, we can send some AT commands through the COM port, for example by using the PuTTY Windows tool. For example, one useful command is to set the Wi-Fi mode. The options are 1. Station mode, 2. AP mode, and 3. AP and station mode. By default, the Wi-Fi module is in mode 2, so it is important to enable the station mode to connect it to a Wi-Fi network so that it can access to the computer in which we have our database. So we recommend setting the module to mode number 3. Thank you very much for your attention and see you in the next lesson.